two semesters also. So this will be the exam. So again, this problem is saying that so you buy a chemical from a company and it's sent in the bottle, right? So it's sent in the bottle. Now you take a little bit of sample, or you can say I take 100 gram of sample, right? So you can take some 100 gram, or you can take a little bit, and you assume that is 100, right? So take a little bit of that sample and throw in your machine. So there is called the instrument called mass spectrometer. When you put 100 gram of sample there in this spectrometer, it is going to count how much carbon is there, how much oxygen is there, how much hydrogen is there. So it will count carbon, hydrogen, and oxygen there. Yeah. So it will show those numbers. So the problem is the same. So when you did this one, the spectrometer gave us a percentage of carbon. Percentage of carbon to be 48%, right? 48%. So carbon was 48% there. Here, so this is carbon is 48%. So if you have put 100 gram of sample in that instrument, that will say you have 48 gram of carbon in that material, right? So that means that percentage of carbon is 48%. So I'm just going to write this is the gram, yeah. So percentage gram, same thing here. Make sense? Good. I assume that I throw 100 gram of sample in the machine, and machine said, oh, you have 48% of the carbon, meaning that 48 gram of the carbon out of that 100, right? Now 48 gram. And another one is hydrogen. So it says we have hydrogen, 8% of hydrogen by mass. So percentage of hydrogen is 8. So that is 8 gram. 8 gram, right? And then the machine says we have oxygen 53.5 gram. So oxygen is 53.5 gram, right? 53. So here 53.5 gram. So I even don't write this percentage. So let's assume that we throw the 100 gram of the material in the spectrometer, and the mass spectrometer told me I have 48 gram carbon, hydrogen 8 gram, 53.5 gram is the oxygen. Easy. Now I look the periodic table. So I go to the periodic table and I look here. So look the bigger number in a carbon. So 1 mole carbon is equals to 12. 12. So look the 12 gram. So look the periodic table. The bigger number is the 12, right? Now another one is hydrogen. Look the hydrogen there. Hydrogen. So 1 mole hydrogen. Hydrogen, look the periodic table. In the head of that hydrogen, the bigger number is 1.00 something. So I don't care that small number, I just round it, yeah? So that's 1 gram. 1 gram. Now oxygen. So oxygen, 1 mole oxygen. Look the periodic table. 1 mole oxygen, 2. So in the head of that oxygen, you will find 15.99, which is 16, right? So I'm going to write the 16 gram. So I don't need gram, this gram. I want to remove those gram here. So I put this factor in such a way that I cancel this gram. So I put that gram, this gram down. I put the mole up. Because I need mole, I don't need gram. Make sense? So I'm going to multiply that with 1 mole part I put up, and then 12 gram I put down here like this. 12 gram. So gram I can cancel, right? So we need to put the factor like that. Easy? So this is important. So now 48 divided by 12 is 4 mole. So I have 4 mole carbon in that sample. Make sense? Now here 8 gram, I divide that 8 gram by, now I don't need this gram. I don't need gram, so I put this gram part down, mole part up. So here I put 1 mole up here and 1 gram down here for hydrogen. And I don't need this gram, I cancel. So 8 divided by 1 is 8 mole of hydrogen is there. Now here with the oxygen, here same thing here, 16. So I put the 1 mole part up and I put 16 gram down here. 16 grams. So gram cancel. So 53.5 divided by 16 will give you 3.3 moles. 3.3 moles. Everybody followed here? Easy, right? So we are just learning how to look the periodic table and convert a gram to mole. Yeah. So here comes the trick. So when you come here, so let's write the formula now. CHO, right? So I'm just doing the CHO. So how many C I have? 4, right? 4 mole of C in that compound. And how many H I have? I have 8 here. And how many O? Sorry. So let's change this one to the whole number first. One whole number. So let's divide this by the smallest number here. So this is 4. This is 8. This is 3.3. So out of all these numbers, 3.3 is the smallest number, right? Because we want to make one species is 1. Yeah. Makes sense? So if I divide this with 3.3, I get 1, right? So one thing I want to make 1, so that my math becomes easy. So there is no other reason why I am doing this one. I just want to make my math easy, so that it's easy to work later. So I just divide this number by smallest one, 3.3. So that smallest is 3.3. So I also divide this by 3.3. So I'm just trying to make life easier by reducing one element is 1. Yeah. Good. So this one, so 4 by 3.3, it gives me 1.2. Put in calculator, this gives me 1.2. This gives me 8 by 3.3 gives me 2.4, and 3.3 by 3.3 gives me 1. So I got one element is 1, right? That's what we wanted to do. Good. So this is that way it becomes easier. Now what I do is CHO. I have these 3 elements in my compound in that bottle. So C I have 1.2, H I have 2.4 moles, and oxygen I have 1 mole here, right? So I have I simplified this like that way. Now this is not a whole number. It's not 1. It's not 2. It's not 3. It's not 4. It's not 5. It's not 6. So it's 1.2. So I don't want to see those point, this decimal number, because in compound there is no decimal number in any compound. Yeah, either they look like this. So maybe a compound look like CS3, C3H8O, something like this. Whole number, whole number, whole number. Yeah. So in chemical compound there is no decimal there. Yeah. Very few, maybe in the D log element. Sometimes you may see something like that, but always the number is whole number. So I'm trying to make this as a whole number. So one time I multiply by 1. So you don't have to multiply by 1. If you multiply by 1, it comes 1.2, 2.4. 1 multiplied by 1 is 1, right? So multiplying by 1 doesn't help much, right? So let's multiply by 2 and see what happens if I multiply by 2. So it comes to be 1.2 multiplied by 2 gives 2.4. See, again I didn't get the whole number, right? Bad, right? So it's worthless doing that because it's still giving me decimal. I'm just trying to get a whole number. Yeah. Now maybe I can multiply by 3. So if I multiply by 3, so 1.2 multiplied by 3 gives me 3.6. Still I'm getting decimal. So if that number comes about 3.9, that will be fine. I will just round that as a 4, right? So 3.6 is still hard to round it. Yeah. So I'm just trying to multiply by a number so that I get all whole number there. So let me multiply by 4. So I multiply by 4 with 4.8. So I got 4.8 here. So very close to 5. How about here if I multiply by 4? 6, 8.6 here. So that's 4 multiplied by 1. So very close actually. So it's very close to 5, right? Yeah. It's very close to 5. This is very close to 9. Can I form a better number than this one? So I try again, yeah? If I make some very close to whole number. So I try with 5. Let's see, multiply by 5. I multiply by 5. 1.2 multiplied by 5 would give me 6.0. Yeah? So that now I get a whole number here. Yeah, so I just keep trying with the number so that I get close to whole number all those numbers. Yeah, so I multiply by 5, and here also I multiply by 5. So yes, so 2.4 multiplied by 5 give me 12, and then I need to multiply this also by 5, and so I get 5. So this is my formula of my compound there in that bottle. Yeah. I just buy a chemical. I didn't know anything about the chemical, what is there, right? And what I did is I take the 100 gram of sample and throw into my mass spectrometer. And mass spectrometer, that instrument gave me, your compound has 48 gram carbon, 8 gram hydrogen, and 53.5 gram oxygen. So I by that way, I come this number, and then I started to multiply by 2, 3, 4. So I have to multiply all the time by one number. If I multiply by this 2, I need to multiply by this 2, also multiply by 2, or 3 and 4 and 5. Yeah. So you are going to get all number like the. So sometimes you will get, if you have got 6.1, so probably you can just write 6 there. Yeah. So we don't write that decimal. Make sense? So this is called empirical formula. Still, I don't know whether this is my compound or not. So sometimes this compound, so I just found that my compound has C3, C6H12O5. Is it really my compound? I don't know yet. So this is called empirical formula. This is the lowest whole number ratio in that compound. So we call this is the empirical formula. Make sense? But is it my compound? I don't know. Is it a compound or not? Sometimes what happens is, so this is one guy, and there is another guy. So two things just clump together and sit together. So this is the real compound. Make sense? Sometimes 3 units clump together and sit like that way. Yeah? So this is the molecular formula. So this one is called empirical formula, lowest possible the whole number of the element, but this is not my molecule. So my molecule may be something like this: C6H12O5 connected with another C6H12O5. So maybe this is my compound. Maybe this is a real compound, right? This one is 1 unit of that compound. So that is called the empirical formula. Make sense? Right? So maybe there are 5 units connected together: 1 unit, 2 units, 3 units, 4 units, 5 units. Just like this is one apartment in a big building, right? And maybe there are 3 apartments connected together: C6H12O5. So this is the molecular formula. This whole is a molecular formula. This is just the empirical formula. What is the difference between empirical formula and molecular formula? Molecular formula tells everything about that molecule. Yeah. So how many units are there, right? But empirical formula only say the ratio of the carbon, hydrogen, and oxygen in the lowest possible whole number. Yeah. Everybody got it? So you'll see something like this in the exam. Yeah. So I tell you, we don't go up to the molecular formula. To get the molecular formula, we need another parameter. So like just like you have a, I tell you, okay, you have an apartment. That apartment has, let's say, 30 meters square. One apartment is 30 meters square. If whole house is, let's say, 6,000 meters square, how many apartments are there? So you need 2 parameters there, something like this, to tell about the molecular formula. Yeah, how big is the house? Yeah, like this. Make sense? So how many units? So if 1 unit has 30 meters square, and you have a whole unit is 6,000 meters square, how many units are there? You divide this number by this number to get the how many units are in the house, right? So just like that. So we don't go there. Make sense? So we only go up with the empirical formula. Good. It's just like we are just measuring the area of apartment where we live, and we don't care about the whole house. Yeah. Good. So you will see this one in exam. Important. Yeah. So not exactly this one, but like this one. Yeah. So there will be, I will put a number so that you don't get confused. I don't put a very confusing number. I will put maybe 2, 3, 5, C2 is 3 or 5. I just make a number so that that comes in the really distinct set of number to put in C, S, and O. Yeah. So we'll see that. Good. So this time again. Now let's go to. Now this one. So the mole concept again. So how important is the mole in chemistry? So if you understand this thing, the chapter 4 will be very easy. So let's talk about the water here. So I have water here. So I say it's a water. So I have water here. So I have water here. How much water I have here? I say I have 18 gram water. I have 18 gram water. So let's look the molecular formula of water. H2O is the water, right? Now look the periodic table, hydrogen. So look the bigger number. One hydrogen is 1.008, whatever. I don't write that small number, I just write 1, yeah? So how many hydrogen I have? 2. So 1 plus 1. 1, and how many oxygen? I have 1 oxygen, and look the bigger number of that oxygen in periodic table. There is 15.99, so you look 16, yeah? Everybody got it? So 16. So this is 1, 2. Now this gives 16. So add all. So that is 18, right? So molecular mass of water is 18 gram. Make sense? So I have 18 gram of water in this bottle. That means I have 1 mole of water. 1 mole of water. So you can say either I have 18 gram of water in this bottle, or you could say I have 1 mole of water in this bottle, because 18 is the molecular mass of the water, right? Make sense? And then, or you could say I have 6.023 into the power 23 particles of water. The same thing. Yeah? Same thing. So this is called Avogadro number. Molecules of water. I have water in that bottle. How much water I have there? I go to the balance and measure the mass. I have 18 gram. So if I have 18 gram, 18 is the molar mass of water. So I could say I have 1 mole of water. And if you have a 1 mole of water, 1 mole have to be starting to count the number of particles. How many particles are there? There are 6.023 10 to the power 23 particles. Make sense? Everybody got it? It's very important. So, like if I say I have 1 mole of student in UWEC, how many people are we have? 6.023 10 to the power 23 people. That number is very constant. The guy named Avogadro found that number, and they call that as a Avogadro number. Yeah. So just by looking this one, we can solve all chemistry problem. I will show something here. Now let's look something here. Some problem. So I have a problem here. So 1 mole of anything has 6.023 10 to the power 23 particle, right? Anything. And this is called Avogadro number. Molar mass of water is 18. So 18 grams of water is equals to 1 mole of water. So we say that one. 18 gram of water is equals to 6.023 10 to the power 23 molecules of water, right? Now let's talk about the molar mass of oxygen. So oxygen is this one. Oxygen. So O2. Oxygen never stays alone. So it stays with another friend O2. Yeah? O2. Now look the periodic table and look at the head of oxygen. You will see 15.99, the bigger number. So that is 16. I have 2 oxygen, so 16. I have 2 16s there, so 32. Make sense? 32 is the molar mass of O2. Yeah. So if I have 32 gram in this bottle, so this is a bottle of oxygen. If I measure in the balance and I found that 32. I have 32 gram of oxygen there. 32 gram oxygen. This was water. This was water, right? 18 gram was water. Now I am talking about oxygen. 32 gram of water. I say, oh, I have 32 gram of oxygen in that bottle. Or I can also say I have 1 mole of oxygen there, of O2 there. 1 mole of O2 there. Yeah, because it is equal to molar mass, right? Or I could say I have 6.023 multiplied by 10 to the power 23 molecules of oxygen in that bottle. Easy? Everybody got it? So you will see this kind of thing in homework. So let's do some problem. So into gram of oxygen equals to that. All right, so here is the problem. So let's do this problem. So it says, the problem says, convert 2.5 moles of lead to grams. So here is a bottle, right? Here is a bottle, and it says there is a, how much moles of lead there? 2.50 mole. Here is 2.50 moles of lead. You never have heard the words like this, yeah? You always say, oh, I have 10 gram of lead or 20 gram of lead, right? Or in mass, you might have said, oh, I have 3 cubic centimeter of lead, something like that, right? But you have never heard so far, I have 2.5 moles of lead, right? So chemists use the mole concept there. Now, I'm going to look the lead here. Lead is PV. So that's a PV. So lead is here, PV. Where is PV? Lead is PV here. Yes, PV. So PV is right there in the P block. So you can see group 4. In group 4, carbon, silicon, germanium, centenium, PV is here, right? So in the periodic table. And then I'm going to pick the bigger number. Bigger number is 207.2. So I don't care that 0.2. I just take 207. Yeah. So 207. So what I write here is 1 mole of PV is equals to 207. I just write that one. There was 207.2, so I didn't have to write that small number there. Now I have to convert 2.50 mole to grams. You can write 207.22, but that gives a really small. That really doesn't make any difference. So you can just write 207. Yeah. So now let's look here. So let's convert this into gram. I have 2.50 moles here. So I need a gram because I need to, this says convert that to gram. So I need gram. So I don't need mole. So I put this factor in such a way that I cancel the mole, and this is a gram here. This is gram, right? So I put that factor to cancel the mole. So mole part I'm going to write down, and gram part I'm going to put up. So now mole and mole cancel. Now I put in calculator 2.50 multiplied by 207 gives me how much? 518 gram. So that's a 518 gram. So if somebody say I have 2.7 mole of lead, I have 518 gram of lead. Make sense? Everybody got it? So let's convert this into molecules. So how many molecules I have? So from gram, you cannot convert to moles. We have to go from moles, yeah? So moles to particles. So let's go from moles to particles. So 1 mole of anything is equal to 6.023 10 to the power 23 atoms or particles, whatever you want to say. So how many particles are there in 2.50 moles of lead, right? So if I started, so if there are 2.5 moles of lead atom, now I started to count 1, 2, 3, 4. So how many are there, right? So that's how many number of particles. So again, this is 2.50 moles. Now I multiply in such a way that I don't need moles, I need the particles. So I need particles, so I need the particle part of 6.023 10 to the power 23 particles. Particles or molecules or atom, whatever they say here, particles. So, and then I don't need that mole part, so I put this mole part down here. So mole cancel. So now I have the particles. So put that number in calculator. So multiply with this one and this one, whatever number comes there, put here and 10 to the power 23 particles. Easy. So something you don't need, just put that down so that you can easily cancel what you don't need. Yeah. And what we need, we put that in. Easy. So from gram, we cannot convert, we cannot reach to number of particles. We need first go from gram to mole, and then from mole, and then we can convert to number of particles. Yeah. Everybody got it? So this is very important. Now you could do this one yourself. Let's see. So you have 36.6 gram tin. How many atoms are there? Now particles. He's asking number of particles. So 36.6 gram. So 36.6 gram. So you have a bottle. In that bottle, you have 36.6 gram tin. 36.6 gram SN tin. So how many particles are there? He's not asking mole. He's not asking gram. This is a gram of tin. Tin is SN. So look at tin. So again, go to the periodic table. Tin is SN. So SN has 118.69. So maybe you could round it to 118.7, or you can use also 118.69. Is up to you. Yeah. So 118.69. So 1 mole of tin. Tin is SN. So that is 118.69. Right? 118.7, and this number is always same. 1 mole is equals to this one. Yeah. So this is gram. From gram, I cannot go to number of particles. From gram, we must go to the mole first. Yeah. There is no relation between gram and number of particles. There is only relation between mole and number of particles. Yeah. So I change this number into mole first. 36.6 gram. So I don't need gram. I need the mole. So I'm going to put that factor in such a way that I cancel the gram. So mole part I put up. 1 mole part I put up, and then gram part I put down. 118.7 gram. Now gram cancel, I get the mole. So you divide 36.6 with 118.7, then you get 0.308. 0.308 moles. Make sense? Because I have only mole here, so mole. Now I have mole. Now I can convert that into number of particles. 0.303 moles. So I need to multiply in such a way that I cancel that mole. So mole, I need to cancel this mole, so I put that down here. 1 mole. And then the number of particles I need, so I'm going to put that in up. 023 10 to the power 23 particles. I need a particles. The question is asking us to find particles. So mole cancel. Now multiply 0.303 with this number, and whatever number comes there, you can get the number of atoms. Yeah. So 308 20. So what number comes there? You just multiply this number and this number. You put it here. Multiply by 10 to the power 23. Get it? Easy? That is very important. Yeah. Really important in chemistry. So 1.86. 1.86 multiplied to the power. Now, the same thing. Can we convert the number of particles into grams or moles? Easy. The same thing. Whatever we don't need, we just put that factor that way, right? Let's do one thing here. There are 8 multiplied by 10 to the power 25 molecules of hydrogen. So let's do this one. So we have the how many hydrogen molecules there? There are 8 multiplied by 10 to the power 25 molecules of hydrogen here. So this is hydrogen. I have 8 multiplied by 10 to the power 25 particles of H2. I counted there 1, 2, 3, 4, and I got that many, right? That many particles of hydrogen there. Now convert that to find its mass into grams. So we need to convert that into gram. So let's do that one. So I'm not talking about H, I'm talking about H2. That's the important thing here, right? We are talking about H2, I'm not talking about H, right? So we need to know that. So 1 mole of H2, 1 mole of H2 is equals to, so 1 H is, because I have 2 H here, right? So 1 mole of H, what? 1.008 something, right? Since I have 2 H here, so 2 gram like this. Yeah. Make sense? So we need to count 2 times, right? Because we are talking about H3, not H. Yeah, so I don't put any confusing problem in exam. So it is very direct, yeah. So there will be no confusion. So 1 mole of H2 is 2 grams there. Now I have that many particles. So so here 8 multiplied by 10 to the power 25 particles I have, particles. So particles. So I need to go to the particle relationship. So mole and particle relationship, right? Because there is no relationship between particle to gram. So particles, now I put this factor to cancel the particles. So this one. So 1 mole. I don't need particle there, so I'm putting the particle down here. So 6.023 10 to the power 23, and then up here is 1 mole. 1 mole. This is particles. Particles. See, I don't need the particle, so I just put the particle part down, right? So I cancel this one and this one, and I put this number in the calculator. 8 10 to the power 25 divided by 6, so that gives me 25 minus 23 would be 2. So 1.32, 1.32 10 to the power 2 moles. I just count the moles, right? You got it? Something I don't need, I just put that factor to just plot that. Yeah. Now I got the moles. When I get mole, easy to convert into gram. So moles. So I have 1.32 10 to the power 2 moles. So I put another factor to cancel this mole and get gram. So here is a gram, mole and gram relationship for hydrogen molecules, right? So I put that there, and so I need gram. So I need gram. I put 2 grams here, and moles is 1 mole there, 1 mole. So mole cancel. So it's gone. So 1.32 multiplied by 2 would be 2.62 10 to the power 2 gram. So I multiply with 2 to this number and just put that. The calculator will give that. Easy? Simple, right? So first of all, you need to know how to look at what is the molar mass, and then just start to cut with that factor in such a way that what you don't need, that should go away. Yeah? So practice a couple of times. So I write the 2.6 to 10 to the power 2. You could write 262 also, yeah? That's the 260. Looks like we are done. So I think chapter 2 is done. So we really learned a lot of chemistry in chapter 2, yeah? So how to write the molecular formula and I think I put some, so maybe I have some practice problem here. So let's look from there. Some practice problem here. Okay, so here are some practice problem. I don't know if I have put there or not. So I'm going to practice a couple of problems here. Looks like I put this in chapter 3 slide, so it's not yet getting here. So I'm going to practice a couple of problems here. Yeah. So it is it's from the book. How many molecules are present in each of the following? So here is the problem. It's saying how many molecules are there in 24 grams of oxygen. So I have 24 grams of oxygen. So he's giving out 24 grams of oxygen. How many molecules are there in 24 grams of oxygen? Yeah. The question is, I need to convert this into number of particles, right? So look the periodic table. So again, I'm working with oxygen here. Now not hydrogen, 1 mole of oxygen. So look the oxygen. Oxygen is the bigger number is 15.99, which is 60, right? But I have 2 oxygen here, so that gives me 32. Yeah, 16 multiplied. So you need to take care of that number, yeah, by multiplying. So 32 grams. Now this is always same for anything. 1 mole is equal to 6.023 10 to the power 20. Yeah. Now that's a gram, right? So that's a gram. 24 grams of oxygen. So I'm just going to convert that one. 24 gram. So I need to convert that to number of particles. Not only mole, number of particles. So first I'm going to convert this into mole. So I put that factor to cancel the gram. So I put the gram part down, 32 gram, and then 1 mole up here. I just convert this into mole. So 24 divided by 32 will give me 0.75 moles. Moles. Make sense? Easy, right? Now I get a mole. Now I can convert into number of particles, right? So I use this factor now. So I have 0.75 moles, but he's asking not to find mole. He's asking me to find the number of particles. So I put that factor to get the particles. I don't need moles. So I put the mole part down, 1 mole, and I need a particle. So 6.023 10 to the power 23 particles up here, and then so mole cancel. I don't need, so you multiply this number with this number, and you get maybe close to 4.2. So you may get 6 multiplied by 0.7 may give you about 4.2. Yeah. So it gives about 4.1. So it gives about 4.1 10 to the power 23 particles of oxygen molecule. Easy. We are doing the same thing. Yeah. We just know one thing. If you know one thing, everything is same. Of the related problem. Yeah, you need to know how to look the periodic table, and you need to know how to put that conversion factor so that you cancel what you don't need. Yeah, good. So that was there. So there are a couple of problems for chlorine, hydrogen, nitrogen. You can try yourself. There is one. So let's do a couple of problems here. So here's the problem. It's from the book. So a compound is composed of 87.42 nitrogen. So it says 87.42% nitrogen and 12.58% hydrogen. So we have a compound like this. So you bring the bottle, you throw in the mass spectrometer, and the mass spectrometer say, oh, you have 87.4 gram nitrogen and 12.58 gram hydrogen. So find what is the thing there, right? So we already solved this problem there. So let's do this one. And I told you, you don't have to write the percentage. So nitrogen, I have 87.42 gram, and hydrogen, you have 12.58 gram. Now, something like this. Now you get the molar mass and convert to mole. So for nitrogen, look the periodic table, and 1 mole of N. We are talking about the N. So N is 14. So N is 14. Yeah. So look the periodic table. The bigger number there is 14. Yeah. Maybe 13.99, maybe 14.10, but it's 14. Now this one, hydrogen is 1. So hydrogen is 1 gram. 1 gram. Yeah. So how? What is the smallest ratio of that compound? So is it NS, or it's NS3, or it's N2S3, or it's N2S6? What is there? Yeah. So we need to find that one. So I convert this gram to mole. So I put the mole down here. So I need mole. I put mole up here. 14 down here. 14 grams. So gram cancel. So 87.42 divided by 14, you will get 6.2. You get 6.2 there. 6.2 mole. And then here I have that 1 mole of hydrogen. This is hydrogen, that is gram, 1 gram here. So gram cancel. This is mole. Then you get 12.58 mole of hydrogen. Now our job is divide both the number by the small number. So this is small number, this is big number. So small number is 6.2. So I am dividing both by small numbers, so that I get one number is 1, right? We are really practice that one. So this is 1 mole of nitrogen, one mole. So this guy give me 6.2 divided by 12.58, give me 2 mole. So this time exact whole number, right? So N is 1, N is 2. N1, H2. Now, both are whole number, so we don't have to do anything. Yeah? So that's the lowest empirical ratio. So if you want to know exact compound, what exact compound is this? There is another number which is given. So that's for empirical formula. Now it gives molecular formula. Here is another number is given. Molecular formula. Molecular formula. Sorry, molecular mass is given here. Molecular mass is given to be 36. Right? A big house. How many apartments are there? Right? Like something like this. So 36. Now you sum this one. So what is this? N1 is 14. N1 is 14. H2 is 1 and 1 is 2. So that is 16, right? So one apartment has 16 area, just like that, yeah? Molar mass of my tiny unit is 16, but in that one, big, there is maybe this NS2 and another unit are connected, and if I get that mass, the molecular mass is 36. So if you divide this one by this one, you get the how many units are there? So that is 32, not 36, 32. Now molecular mass divided by empirical formula mass. Yeah. So this is like the big house, right? And this is like the one apartment. Make sense? So how many apartments are there? Something like this. Or how many units are there, right? So that is 32 divided by 16 give me 2. So I have 2 units in that compound. So this is 1 unit, and I need to connect this with another unit. So N1 H2 is 1 unit, and it is connected with another unit N1 H2. I have 2 units here, like this. Yeah. Make sense? So when I have a molecular formula and empirical formula mass, I divide the molecular formula, the big number, by small my number, so that I get how many units I have. So I have these 2 units in that compound. So this is the real actual compound. Yeah. So now you could write this as like N1, N1. So you could write as N2. I have 2 N and I have X2, 2, 4. You could write like this. Yeah. So this is a big house, which is a real thing. Yeah. So apartment 1, we cannot say much thing, right? So we need to give the house number to the people so that outlater comes in our house, right? So that's more reliable meaning. That's right. So my house number is 941, right? My apartment is 25. So if I just write the apartment 25, not enough to come my later, right? But if I say my house number is 941 and I have this number, something like this. So that is the molecular formula, is the actual compound. Yeah. So when you have an empirical formula, you need to find molecular formula they give, and you divide the molecular formula by empirical formula, you get the number of units, and you just connect those units. Yeah. Good. All right. So looks like, yeah, we are almost done. So we will start chapter 3 next class, and I will just give you a couple of molecules there, name, and we will start chapter 3. Just understand one thing and try to apply that everywhere. Yeah. So just repeat unless until you know one thing in that. Yeah.